Hi, Assalamualaikum. So let's solve the Fourier series of signal xt given here. So the question refer to the periodic signal xt as shown in figure question 3a here. Identify the fundamental period t and angular frequency omega. So the first thing, the characteristic of the signal, if we want to produce the trigonometric Fourier series, the signal must periodic. If the signal is periodic, then this signal have a period t. So how to find t? So by looking at this signal from 0 to 1, the signal like this, and then from 1 to 2 here, it's considered this one if one cycle, because of after 2 the signal is repeat the same pattern. So this is considered one period t. So t is equal to 2. If t is equal to 2, then omega is equal to pi over t. Then omega is equivalent to pi. Okay. Okay, let's test next the symmetry properties of this signal. So this is one cycle, and then for even symmetry, okay, you need to draw the first half cycle first. Okay, until 1 only, because this is half cycle. So you need to produce another one cycle to get one period, and then for even symmetry you need to flip at y-axis, so it will become like this. So you will produce this pattern is not the same with the original signal, so the signal is not even symmetry. So how about odd symmetry? So again, the half cycle here. Okay, for the odd symmetry, first you need to flip like even, flip first, and then flip 2 times. So until, oh sorry, this one is not 1, this one is 2. So until -2, it will become like this. Then when you compare with the original signal here, the signal is look the same. So yes, this signal is odd symmetry. Okay, so the symmetry properties have 3 types. So even though you already found the odd symmetry, so don't forget to test for the half wave symmetry. So how to find the half wave symmetry here? You need to draw the first half cycle first, and then the technique is like odd symmetry, but the first step is not reflected, but the first step is shifting. So when you shift, the signal will be coming like this, and then after you shift, you need to flip, and then it will become like this. So this pattern is not the same with this original signal. So this one is also not true. So only got odd symmetry for this signal. So after you done to test the symmetry, so refer to the table of the Fourier series symmetrical table. So you can found that something like this, which is for the odd symmetry, you need to calculate only Bn. So as you know previously, basically Fourier series have 3 coefficient you need to count, which is A0, An, and Bn. But if the signal is odd symmetry, so there are no element of An and A0. Um, that means A0 is actually equal to 0 and an also equal to 0. So the properties now is only Bn. After you calculate Bn by using this formula, and then you just substitute the Bn here to get the series of xt. Back to the question here. This is the formula for calculate Bn for the odd symmetry signal. So T is 2, and then you just substitute here 4 over 2. And then you need to integrate from 0 to, okay, 2 divided by 2 is 1. So you need to integrate only the lorex area here, the blue area, from 0 to 1 only, because t over 2 is half cycle. So xt is, you need to find the equation here. So the equation here, xt is equal to what is m t plus c. So the m is slope. Slope is, you need to calculate the slope here. So when you use the rumus or formula of y over x, so the slope is equal to 2. The slope is positive. And then the c is intersection at y-axis. So you can find the intersection is at 0. So the xt is equal to 2t. So you need to put here something like this. And then times sine. Okay, something like this. Okay, and then okay, let's solve this one. So how to solve this one? This is you need to use product rules where you need to find what is u. U is for this case, u is t. Du is equal to dt. And then the left is v. V is integration of sine. So sine is negative. Cos and omega naught t over n omega naught. Okay, so here 4 divided by 2. So 2 here, I will put it outside because it is not required in the integration process. So I can cancel this one, and then I get 4. And then when you are doing the integration by part, you need to find uv minus integration of v du. Okay, so what is u now is t times v is negative cos n omega naught t over n omega naught. So this one in the range of 0 to 1. Okay, you just put the range later, and then you need to integrate from 0 to 1. Okay, so this one is negative cos. Okay, later on I will put the negative. So du is dt. Okay, so actually this one have a negative here, right? So I don't want to put the negative there, but I would like to put here a positive, which is negative times negative will produce positive. Okay, so then let's solve here. Okay, Bn is equal to, okay, sorry, this one the big, okay, kurungan. Okay, t is the range 1 until 0. So first you put 1. So 1 times times negative cos And okay, omega here, you need to replace the omega with pi. Okay, where I get pi here. Before this, you already calculate here pi. Okay, the highlighter yellow here, pi. Omega is equal to pi. So depends to the period. The value of omega is depends. So this all the yellow lighter, I will substitute with pi. So n pi t is equal to 1 over n pi minus. So next I will put 0. So 0 times with any cos 0 is equal to 0. Okay, this one plus. Okay, so here the denominator here I will put it outside because it is not required in the integration process. So 1 over n pi. And then I will integrate cos. So integrate cos will produce sine. So it will result to sine n. So this one is omega is pi over n pi. Right. Okay. The range is 0 to 1. And then okay, this one we refer to okay, the cos. Okay, this one also have inside the notes. Okay, can you see that this one is cos graph. So cos n pi actually for the all integer cos n pi is actually negative 1 to the power of n. So this one you may refer to the notes of cos function, cos graph. So I will get, okay, cos is negative 1 to the power of n over n pi. Okay, so this one 1 over, so n pi square. So for the sine, it will be coming sine n pi minus sine 0. Okay, so let's see to the sine properties here. Sine n pi, sine 0 is 0. But amazingly, sin n pi here is 0 also. Sin n pi only have value if sin n pi is sin n pi per 2. Okay. So here, okay. Here, it will result to sin n pi is 0, sin 0 is 0. So this part is 0. So the result is Bn is equal to negative 4 over n pi negative 1 to the power of n. So n is a harmonic for all integer. So from this you can draw the Fourier series by follow the table of Fourier series. So Bn, so actually the general is Bn sine n omega t. So you just substitute the Bn value inside this Fourier series of xt. So you will get Bn is negative 4 over n pi negative 1 sine n omega naught t. Okay, that's all. Good luck.